But in 1979 at Harvard University, Robert Epstein and B.F. Skinner began a unique series of experiments which brought complex behavior into the laboratory. Prompted by increasing reports from primate laboratories in which behavior was attributed to mental processes, they began confronting head-on some of the thorniest issues in the analysis of complex behavior.
One very good example was a paper which claimed to show that chimpanzees could communicate with each other, expressing ideas and so on.
They did tell you about the extensive training that their animals had, and they then turned around and attributed the behavior they were observing not to the training, but to the information and knowledge that the chimps possessed, to a message that was being transmitted from one to the other, to the intentions of the chimps and that kind of thing. In other words, they turned around and interpreted this behavior in everyday human cognitive terms.
And so we arranged a situation in which pigeons would do even more complicated communication, if that's what you're going to call it, and did indeed succeed in getting what certainly looks like the behavior of a speaker and the behavior of a listener.
Epstein and Skinner, with colleague Robert Lanza, trained two pigeons whom they named Jack and Jill. Over a 5-week period, using standard laboratory techniques called shaping, fading, chaining, and discrimination training. Jack and Jill could observe each other through a clear plastic partition and could each peck plastic keys on the panel in front of them. Jack's task was to peck one of 3 colors, red, green, or yellow, which matched a color only Jill could see. When conditioning was complete, Jack, the bird on the left, initiated each exchange by pecking and thus illuminating a sign on his side of the partition labeled, "What color?" Jill, the bird on the right, then thrust her head through a curtain on her side of the chamber where a color was illuminated. She then pecked the corresponding letter on her panel. R for red, G for green, and Y for yellow. Having seen this, Jack pecked a sign labeled "Thank you," operating Jill's feeder for a few seconds. Finally, Jack pecked the color key corresponding to the letter Jill had illuminated. And this response operated Jack's feeder for a few seconds. After feeding, Jack then initiated a new exchange.
So what we had done was show that that some environmental history, a certain set of experiences, if you will, can produce very complicated language-like behavior in simple organisms.
We had an apparatus in which we had one pigeon talking to another, and we exchanged the roles. They could go either way. Either pigeon could be a speaker and either one could be a listener. It was a natural thing to do, to take out the partition and put just one pigeon in and see whether it would, in a sense, talk to itself. And that's what actually happened.
After a few minutes in this situation, a smooth sequence of behaviors emerged. Jack thrust his head behind the curtain where the color was illuminated and then, although not required to do so, pecked the corresponding letter key. He then moved to the left side of the chamber and pecked the appropriate color key, often looking back at the illuminated letter key. It seemed the pigeon was using the letter keys as humans use a memorandum. In casual terms, the pigeon pecked the letter key to help it remember the hidden color. Both birds repeated the sequence thousands of times.
Well, we feel that under these circumstances, two repertoires which we had set up separately, speaker and listener, actually came together quite spontaneously. We did not train the bird to use a memorandum. We trained it to be a speaker and a listener, and quite without exception, it began to talk to itself.